Hi guys. Today I'll be teaching you how to do number 16 in lesson 3.4. And so number 16, as you can see here, Kim holds up a scale at rest against the wall, and we have to draw the force diagrams of the scale and of the person. And you get the masses. The person's mass is 60 kilograms. The scale's mass is 2, and then we get the force units. Important equations, remember, F net equals ma. And then what this basically translates to is because you're not accelerating, because you're at rest, F net's going to be 0 at all times. So it's just equals 0. And then also, in terms of calculating force of gravity, Fg equals mg, or and then g equals 10. And then finally, in terms of, we'll get to that. So first up with the scale, right? So the scale here, A. Kim's applying a pushing force into the wall this way. F push. The wall is also going to be pushing back as a result because these two forces are going to be equal because, again, no acceleration. So F norm. The scale has a force of gravity because it's an object on Earth. So it's going to be getting pulled down. And in order to counteract that, because again it's at rest, there's going to be a force of friction between the scale and the wall. F fric, right? And so, first off, the Fg of the scale, 2 kilograms times 10 units per kilogram. Fg equals 20 newtons. F fric has to be equal to that, so equals 28 newtons. The scale's reading, the reading of the scale is like what the normal force the scale applies, or the force applied to like where the person pushes. And so it doesn't matter which side the scale reads on, this side or this side, because again it's going to be equal. But let's just say it reads on this side. In this case, what that means is that the person is pushing into the scale with a force of 100 newtons, and the scale is pushing back onto the person with a force of 100 newtons. So F norm equals 100. Oh, no, F push equals 100. And then, well, F norm will also equal 100 because, as a result, again, you're not accelerating into the wall or out of the wall. You're staying at rest, so F push has to be equal to F norm. So that's A. For B, Kim scale. Kim is a person that has mass, so she's going to have a force of gravity going downwards. In order to keep her up and like not have her fall to the floor, there's also F normal applied by the ground. There's also F normal applied by the scale this way because she's pushing against it. And finally, in order to keep her in place, there's a force of friction. As we said before, F norm here will be 100 newtons because that's what the scale reads, and that's the force that she pushes back with. And then as a result, since she stays in place, F fric will also be 100 newtons. Force of gravity, it's mg, so 60 times 10 equals 600 newtons. And then finally, since she's not falling through the floor, there's F normal being applied by the floor that's going upwards of another 600 newtons. And that's it.